A lens is a piece of any transparent substance that has at least one curved surface. Now we know that light is going to refract through whenever it changes mediums, goes from a more dense to a less dense, or from a less dense to a more dense medium. There's going to be a refraction or bending of the light. And we, as human beings, have worked out that if we have what is known as a biconvex lens, and you get a biconcave lens. Now what you need to realize, can you see that this looks a little bit like a cave? So that's your cave, and then the vex is the other one. You also get ones that are flat on one side and then just convex on one side, or flat and then come across and then are only concave on one side. But we're not going to worry about those in school at the moment. All we're going to worry about is what happens if we go through a biconvex or a biconcave lens. A convex lens brings the light rays, refracts them together, so they converge. Converge in English means that you come towards one point. A concave lens pushes the light rays away from one another, and they diverge or go in opposite directions or away from each other. However, if we were to bring them back, there would be an imaginary point where they would come together. Now, on a biconvex lens or converging lens, the point where all the light rays come together is known as the focal point. It's a real focal point. The actual rays get there. Whilst this is an imaginary or a virtual focal point. We have to imagine that the rays came from that point. So a light ray that goes through the center of any lens, and with the center of the lens, this light ray goes through the center over there, and that does not bend at all. If I were to send a light, that went a bit skew. If I were to send a light ray straight through the center at any angle, wondering why that keeps bumping over there. Anyway, or through like that, there's another bump. You land up that any light ray that goes through what is known as the optical center of the lens does not bend. So the same thing is true over here. This light ray does not bend. That one doesn't bend. That one doesn't bend, as they're going through what is known as the optical center of the lens. They do not change direction. We need to have a whole lot of definitions before we can start doing what is known as drawing ray diagrams. So let's take a look at that. The optical center we've just discussed is that point in the middle of the lens where no light ray bends as it goes through. A point in the lens through which light passes without changing direction. The principal axis is this main line along which everything is staged. It's where we mark the optical center, it's where we mark our focal points and all of that sort of thing. So it's a line going through the center of the lens. Principal focus or focal point, and we tend to call it the focal point more, is the point where light rays parallel to the principal axis converge to, or think that they are diverging from. If this was a diverging lens, you would find that it would imagine that the light ray came from there and then continue from the lens. So that is your focal point or your principal focus. The focal length is this length from the optical center up until the focal point. We can double that length and we get what is called twice the focal length. And so you have f and 2f, f and 2f on either side of the axis when you are labeling an axis. When I'm drawing a converging lens in shorthand, I draw something that looks like a double arrowhead. When I'm drawing a diverging lens, I'm going to put my arrows that way. So there's your cave and there's your vex. You're going to now do a experiment to determine the focal length of a biconvex lens. Okay, there it is. And you're going to use something called the sun, and you're going to get the light rays to come until they reach a point, and you can use a little leaf over here, and when you start getting a fire, or not even a fire, but you can certainly see when you're on a spot and it's burning, at that point, that is the point where you measure this length, because that's where the rays all come together, and that is called the focal length. Once you've got the focal length, you're going to come back up to the classroom, going to have a candle, and you are going to measure out using chalk a number of points along a principal axis. And you are going to put your lens over here, and you're going to put an object, and the object is going to be a burning candle. And you're going to see where you form an image. So the first part of the practical is to determine the single spot, and therefore the distance from the lens to that single spot or the leaf or whatever, and that's your focal length. You're then going to put the lens in a fixed position, and you're going to move the candle at all of these points. F, to F, between F and the lens, between F and 2F, beyond 2F, and you're going to then see where you get an image on this screen over here.